Hi guys! So for today's lecture, we'll be talking about integer exponents in algebra. So let us recall the definition of an exponent or an exponential expressions. So here we consider this symbol. We have a and then there's a superscript n, and this is read as a to the power n or a raised to n. And in this symbol, a is called the base and n is called an exponent or the power. And the whole symbol a to the n is an exponential expression. Now, if n is a positive integer, then this symbol a to the n will be defined as a times a, etc. until times a, where you are multiplying a with itself n times. So there will be n factors of a in here. And take note that this only works when n is a positive integer. Of course, if n is not an integer, then there will be a different definition for the symbol or for the exponential expression. So, these are the properties of exponents or laws of exponents that we will be using all throughout the course. So let a and b be real numbers and m and n be positive integers. So first property is the following. If we have a raised to the power negative n, so meaning we have a negative exponent, then this a raised to negative n is equal to 1 over a to the power n, provided that a is not equal to 0. So meaning, if you have an exponential expression with a negative exponent, what we do is we put it on the denominator. And conversely, if you have an expression where in the denominator there is an exponential expression with negative exponents, you will put the expression in the numerator and then replace the exponent with positive exponent. So we will see this later in the example. Next property is that when you have two exponential expressions with the same base and you multiply them, for example this one, a to the m times a to the n, what we do is we copy the base of the exponent and then we add the exponents in the exponential expressions. So a to the m times a to the n, this is equal to the a raised to the power m plus n. So again, you have two exponential expressions with the same base and you multiply them. So what we do is to copy the base and then the exponent will be the sum of the exponents or the powers in the exponential expressions that you multiplied. So a to the m times a to the n equals a to the m plus n. Okay? Next property, this time suppose we divide the two exponential expressions with the same base. So what we're going to do is instead of adding the exponents, we subtract the exponents in the following manner. So you have a to the m divided by a to the n. This is equal to a to the power m minus n. So notice, this law here or this property here is derived from these first two properties. Okay? So notice 1 over a to the n, it is equal to a raised to negative n. So this 1 over a to the n here can be replaced by a raised to negative n. And using this property here, what we are doing in this expression here or in this quotient here is actually multiplying a to the m times a to the minus n. Okay? So applying this property, we actually get a raised to power m minus n. Okay? Now, next property. Suppose we have an exponential expression a to the m and then we raise it to the power n. So you have a to the m raised to the power n. What we do is to copy the base and then just multiply the exponents that we see. So in this case, you have a to the m raised to n. This is equal to a to the power m times n. So you just multiply this power m by the power n. Okay? Next property. Now, suppose we have two real numbers a, b, and then you multiply them, and then you raise them to power, you raise the product to power n. So what we can do is simply multiply a to the n times b to the n. So this means that we can distribute the exponent over product of numbers. So there's a product AB, and then you raise the product to the power n. This is the same as multiplying a to the power n times b to the power n. So again, we can distribute the exponent into the products of numbers. Next property, of course, we have multiplication. We also have division of real numbers and then raising it to some power n. So here we have a divided by b, and then you raise the a divided by b by the power n. Okay, so you can distribute the n to each of the numbers here. So a over b raised to the power n, this is equal to a to the n divided by b to the n. So take note that b should not be equal to 0. Otherwise, the number will be undefined. Okay? Because b is on the denominator. Next property, if a is not equal to 0, then a raised to 0 or a to the power 0, this is always equal to 1. So again, any non-zero number when raised to power 0 will be equal to 1. Okay? But what happens when we have a equals 0? So this guy here, 0 to the power 0, this is undefined. So this is not defined in mathematics. Okay? Now, I just want to give a big warning in here. Okay? So in this bullet here or in this bullet here, we saw that we can distribute the exponent n over the product of numbers a, b. Okay? But in here, you have a plus b to the power n. This is not always equal to a to the n plus b to the n. Meaning, you cannot just distribute the exponent over the sum of a and b. So there is no distribution of exponent over sum of numbers. Okay? So let us consider these examples. First, you have 4 cube. And 4 cube by definition, it's just 4 times 4 times 4. So if you multiply them, you will get 64. Okay? Next example, we have 2 to the power 2 times 2 to the power 3. So for the sake of using the one of the laws of exponents, we write this or we rewrite this as 2 to the power 2 plus 3. So you have the same base. The base is equal to 2, okay? And you are multiplying these two exponential expressions. So all we need to do is to add the exponents, okay? And use the same base. So here, 2 to the 2 times 2 to the 3, this is equal to 2 to the power 2 plus 3. Or simply, this is 2 to the 5. And if we calculate this, this is equal to 32. Next, we have 5 raised to negative 2. So here, we have a negative exponent or negative power. So what we do is we put this 5 raised to negative 2. We move the expression in the denominator and change the exponent to positive exponent. So 5 raised to negative 2, this is equal to 1 over 5 raised to the 2. And we know 5 raised to 2, or that's 5 times 5, we will get 25. So here, we have 5 raised to negative 2, that is equal to 1 over 25. Next example, in here, we have 2 to the power 2 times 2, or times 4 to the power 2. So again, for the sake of the laws of exponents that we discussed, okay, what we're going to do is to combine this into a single expression with a single exponent. Notice, so what I'm saying is notice that the exponent of 2 here is 2 and the exponent of 4 here is also 2. So they have the same exponent. So this expression 2 to the 2 times 4 to the 2 can be written as 2 times 4 raised to the power 2. Okay, so same exponent. So that becomes the exponent on the outside. And then we just multiply the bases here. So 2 times 4 raised to the power 2. And this is equal to 8 raised to the power 2. And this is equal to 64. Next example, we have 2 over 3 raised to the power 2. Okay? So let us rewrite this as a fraction with in this way. So this one is the same as 2 divided by 3, and then you raise it to the power 2. And then remember, we can just distribute the exponent to each of the numerator and denominator. So this one becomes 2 to the power 2 divided by 3 to the power 2. Okay, so we just distributed that exponent in each of the numerator and denominator. So if we simplify this, we have 4 over 9. Okay? Next, here we have 1.025 and then we raise this to power 0. So this is a non-zero number. Raise it to power 0 and that is equal to 1. Okay? And then final example here, we have negative 1 over 3 raised to negative 2. So in here, like in this item, we rewrite it this way. So negative 1 divided by 3 raised to the power negative 2. Okay? So what we can do is to distribute that negative exponent to each of the numerator and denominator so that we will have this. So we have negative 1 raised to negative 2 divided by 3 raised to negative 2. Now, in the numerator, it has a negative power. So what we're going to do is to bring the expression in the numerator to the denominator and change the exponent to positive exponent. On the denominator, we have an expression with negative exponent. So what we're going to do is to bring that expression from the denominator going to the numerator and then change the exponent to positive exponent. So this means we will have this guy here is equal to is equal to 3 raised to power 2 divided by negative 1 raised to power 2. So again, when you have an expression, an exponential expression with negative exponent in the numerator, you bring it to the denominator and then change the power to positive. And if you have an exponential expression in the denominator with negative exponent, you bring it up to the numerator and then change the exponent to positive. So in here, this one now is equal to 9 over 1 or simply equal to 9. Now, take note that the negative here, what we did is to attach the negative in 1. But this expression has 3 other phases. This negative can be written outside that 1 over 3 here, but still inside the bracket. Or this negative, you can attach it with 3 on the denominator. Okay? But keep in mind that in here, the negative is inside the bracket. Wherever you put your negative here in this form, it must also be inside the bracket. If you put the negative outside the bracket, or if you remove the brackets, then there will be a different answer. Okay? So we will have to recall that one later in the course. But for now, try to review what the rules in bed mass. Okay? The rules in bed mass. Okay? So, these examples that we saw, this guy here and these guys here, we actually use actual numbers. Okay? So here, what we actually did was arithmetic. Okay? So what does it mean if we have integer exponents in algebra? So the difference is that in algebra, we use characters and symbols and letters. So for example, in here, you will see X, or you will see A or B, or you will see Z or Y, or any other characters or letters that is involved in your expressions. These characters or letters, they represent some number. We don't know what those numbers are, okay? We need not specify the numbers. But later in the course, what we're going to do is that if we have an expression with letters, we will replace it with some number. Okay? There is a topic in our course where we need to replace these letters or these characters here with a specific number in order to solve our main problems. But for this lecture, what I want to emphasize is that the integer exponents in algebra only means that there are letters or characters already involved. We call them variables. Okay? The actual values of those letters or characters vary. Okay? Vary depending on your situation or depending on the need in the problem. Okay? So these expressions here, these examples here, we will do them during our discussion. Okay? So for now, try to work on them. Try to use the laws of exponents. And then we will see the solution during the discussion. Okay? And as an offline work, try to work on page 10 of the 016 module that you have. Okay? So that's the end of the video for this lecture, and hope to see you later in the discussion.